Hi everyone, this is Miss Afric here. Today we're going to be talking about the law of cosines. Alright, shouldn't be too surprising that there's a law of cosines since we just learned about the law of sines, right? Both of them get their own law. Okay, and law of cosines, just like law of sines, applies to any triangle, not just the right triangles like we talked about last chapter. Applies to any triangles now. Alright, so you'll see some similarities with the law of cosines and actually the Pythagorean theorem. But they won't be exactly the same because Pythagorean theorem only works for right triangles, whereas this law works for any triangle. Okay, the law of cosines says that given this triangle as labeled, so I would make sure you have that triangle written down, we can write the law of cosines as a squared equals b squared plus c squared minus 2 times b times c times the cosine of angle A. And there's one form of the law of cosines. So you should see, if we just looked at this part, it would look identical to the Pythagorean theorem. Right? But since this is for any triangle, not just right triangles, we have to add this little extra piece there. Alright, now this formula would still work for right triangles, and you should actually, it's an interesting point to make, and you'll be trying to figure it out later, why this still works for right triangles, right, where the Pythagorean theorem comes from. But the most important thing right now is to recognize this is the law of cosines. Alright, now there are two other forms of the law of cosines, because notice how this form only includes angle A. Well, sometimes we might have angle B or angle C. Alright, so there are two other forms involving angle C, or angle B and angle C. We have b squared equals a squared plus c squared minus 2ac times the cosine now of angle B. And the last form you would see is c squared equals a squared plus b squared minus 2ab times the cosine of angle C. Now, we wouldn't expect you to memorize these formulas, but as long as you start recognizing the pattern that's happening here with all three of them, you should be able to reproduce the law of cosines if you needed to. Alright, notice how the angle should always match up with the side on the other side of the equal sign. So angle A, side A, angle B, side B, angle C, side C. Okay, and then the other two sides should always be the ones kind of in between them. So B and C, B and C. Alright, for that first one. For the second one, A and C, and so on. Alright. Just like law of sines, law of cosines has certain situations that you need to use law of cosines instead of law of sines. Okay, so we would use this if you were given a side angle side triangle. So if you were given two sides with the included angle, that's when we would use law of cosines. And the other situation is if you were given side, 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 all three sides. Okay, just a little tip. If you're ever not sure whether to use law of sines or law of cosines, you can always try law of sines. And what you'll notice is in these two situations, law of sines won't work because you won't be able to solve for anything. You'll have too many of the wrong variables. You won't be able to actually set up an equation to solve anything. That's how we know it's the law of cosines. Oops, don't cross it out. The law of cosines that we're going to be using. Alright, so let's take a look at an example. In example 1, it says solve triangle ABC with B equaling to 81 degrees, A is 22, and C is 19. Now remember, again, these triangles are not right, so I'm just going to draw a random triangle here, not to scale. Label it A, B, and C, and I know B is 81 degrees. Side A is 22, and side C is 19. So right off the bat, you should notice that we have a side, angle, side situation. Side, angle, side. And that should hint you off to use law of cosines. Okay, in this specific example, we were given angle B. Alright, so in order to solve triangle ABC, important to know what we're missing. Alright, I'm missing side B right here. I'm missing angle A, and I'm missing angle C. Alright, I'm going to solve for that missing side first. And in order to solve for the missing side, the reason I want to do that first is because I know that angle. So I know exactly which form of law of cosines I'm going to use. I'm going to use b squared equals a squared plus c squared minus 2ac times the cosine of angle b. And the reason I'm using it is, again, because that's the only angle I know is b. So I have to use that form. Alright, when I plug everything in, b squared, I don't know b, but a is 22, c is 19, once again, a is 22, c is 19, and then we're multiplying by the cosine of b, which is 81 degrees. You know that you use the right form if you only have one variable in the equation, because if we had more than one variable, we wouldn't be able to solve. Alright, now if you take a look at this, in order to solve for b, alright, I need to evaluate this, and then I'm going to take the square root to get rid of this square. Well, what's nice about this is there are all numbers here, so I can use my calculator. Alright, in my calculator, I'm going to type this entire right side straight into my calculator. So, go ahead and try this along with me to make sure you're typing everything correctly, because that's a big mistake that people actually make when we shouldn't be typing incorrectly. That's a silly mistake, right? So let's make sure we're typing it in correctly. 22 squared plus 19 squared minus 2 times 22 times 19 times the cosine of 81 degrees. Now make sure you're in degrees, otherwise you'll get a different answer. So double check that calculator. Right. And there's my number. Now, beware, that's not our side b, right? That would be too big. That wouldn't make sense. This is instead b squared. So in order to get just b, right, b squared is 714 point, what was it? 221. Well, in order to get b, I'm going to take the square root of both sides. Alright, and I'm going to do that on my calculator really easily, second, and then to get that square root, and to get this exact number without having to round, second, and then the negative symbol. That way it just takes the last answer you got. So side B is going to be 26.72 units. So there's one piece of the puzzle solved. B is 26.72. Now I'm going to move on. Okay, B 26.72. Now I'm going to move on and solve for my angle A right here. I'm going to use my law of cosines again, but now since I'm trying to solve for angle A, I need to use the form that has an angle A in it. So I'm going to use A squared equals B squared plus C squared minus 2BC times the cosine of angle A. Alright, so let's go ahead and plug everything in. A I know is 22 squared. B is 26.72 squared. I'm going to be running off the page a little bit here, so hopefully you've got some room. C is 19 squared minus 2 times 26.72 times 19 times the cosine of angle A. Now, with this problem, first of all, we know we plugged it in right because I only have one variable, so that's good, right? But in order to solve for that variable, I can't just type it all into my calculator because there's a variable on this side. All right, so I'm going to have to kind of do this piece by piece. I like to do this first piece together in the calculator, and then this second piece together in the calculator, okay? And obviously, 22 squared we can calculate. So 22 squared is going to give us 484. Let's go back to the same color I was using. 484. Alright, 26.72 squared plus 19 squared is 1074.9584. 1074.9584. I really don't like to round too early because otherwise it can give you a messed up answer sometimes. So I try not to round if possible. And then I'm going to type the second part in. So it'll be minus, and then I'm doing 2 times 26.72 times 19. 1015.36. Alright, the reason I did those in pieces is because if you take a look at these two parts, what you should really notice is that those are not like terms. And the reason that's important is you have to recognize I can't actually subtract that. Right? This has a cosine of a attached to it. This one doesn't. So since they're not like terms, I can't actually subtract that. Instead, what I'm going to have to do is move this piece over to the other side by subtracting it. So I'm going to subtract 1074.9584 from both sides. And what that'll do is move it over, and we'll become that much closer to getting our a value alone. So in my calculator, 484 minus 1074.9584. Negative 590.9584. So and that's going to equal negative 1015.36 times the cosine of a. So now to solve for a, I'm going to divide by this negative 1015.36. So in my calculator, divide by negative 1015.36. 0.582, that one I'm going to round because that's just too many numbers to write. 0.582 equals the sine, oh no, where'd it go? Oh, there it is. Equals the sine of angle A. Okay, and now hopefully you remember from the beginning of this chapter, if I'm trying to get A alone here, we can't divide by sine. That doesn't work, right? To get rid of a sine, we have to do the sine inverse on both sides. Alright, sine inverse and sine cancel out, so we're just left with A. And in my calculator, I'm going to do sine inverse, and I'm going to do that second answer thing again. So we got 35.59. And remember, this is an angle, so it should be in degrees. So we've got one of our angles, 35.59 degrees. Now I just have my angle C to solve for, and that should be the easy one because I now know two of my angles. Alright, I know angle B is 81 degrees and I know angle A is 35.59. So I just have to subtract from 180. So C is going to equal 180 minus 81 minus 35.59 degrees. So 180 minus 81 minus 35.59, 63.41. And there's my three missing values, and therefore I have solved this triangle. Whew. I know it's a lot of work. The law of cosines can be a little long the first few times you're doing it, but the more you get used to it, the faster you'll get at it. Okay. Alright, what I want you to do is see if you can try example 2. Okay, if not, we'll go through it in class, but try it just in case, because if you're getting the hang of it, it's good to know right off the bat so you can come into class confident. Alright, if you go down or go back to the back of your page, I just want to help you set up example 3. Alright, and then we can finish that one in class. Example 3 says a 15-foot length of pipe and a 20-foot length of pipe for a sprinkler system are connected in the ground at a 50-degree angle. So that means here's my 15-foot length of pipe, my 20-foot length of pipe, and they're connected at a 50-degree angle. So 15 feet, 20 feet, and there's my 50-degree angle. Well, with these problems, we always want a triangle, so we should know to connect these. And it says, how far apart are the pipes at their ends? So, how far apart are the pipes at their ends? Well, here's an end of one pipe, here's an end of another pipe. So we're actually trying to solve for this missing side. And since here we also have side, angle, side, we're going to go ahead and use law of cosines. Alright, this one's a little bit shorter since we're only solving for one piece. So if you want to try this one also, be my guest. Otherwise, like I said, we will go over these problems in class. Alright, if you need to review anything that we just did in the video, rewind, watch it again, right? Especially if you didn't have your calculator, Watch it again so you can check things with your calculator. And otherwise, we'll see you in class the next time we meet. Enjoy!